A very useful tool for measuring the height of objects you can't conventionally measure is to use this device called a sextant. Now what you're looking at really is nothing more than a protractor with a string attached to it. But the nice thing about the weight attached to the string, gravity always pulls it straight down. The nice thing of having something that hangs straight down always is it gives us a nice reference point. From this reference point, we want to measure an angle that will help us calculate the height of the object we're measuring. To do this, we simply need to aim our sextant at the top of the object we're trying to measure the height of. Once the sextant is aimed at the top of the object, the string that hangs from it will make it very easy for us to record an angle from this tool. Now the purpose of a sextant is to help determine the height of an object, but a sextant does not measure the height. It only measures an angle. To find out that height, we need to be able to integrate a little bit of trig, a little bit of triangle math into our measurement. Let's go outside and make a measurement of the height of this flagpole. Now I say measurement, but we actually have to calculate that. The only measurement, remember, we can make with the sextant is a measurement of angle. Aim the top of the sextant at the top of the object you want to measure the height of. Once it's aimed at the top of the object, as long as the string is hanging straight down without any interruption, such as a finger, and Mr. Schleck, get out of the way. There we go. Now we are ready to make our measurement. The string points to a certain location on the sextant. It is pointing to 122.5 degrees. If we compare that to the 90 degrees, we can quickly calculate the angle between the 90 and where the string lies. The measurement we want to make on this, the angle we want to measure, is always the angle from where the string hangs to the 90-degree mark. As you can see here, the angle between these two is 32.5 degrees. I'm going to count the number of paces it takes for me to get to the flagpole. Maybe it's useful. We'll see. Now that angle we measured was only a piece of a triangle, with the angle being at one part, the height of the object we're measuring being another, and the distance from where we're making the measurement to the object as another. I took 20 steps from where I made the measurement to the flagpole. This is useful because I know the length of one step. If I take the length of one of my strides, multiply it by the number of steps I have, I can find the distance to the object I'm trying to measure the height of. With a little bit of trig, we'll have no problem solving this triangle for the side we need. We know an angle, we know a side, we can find a third side. Alright, quick trig review. SOHCAHTOA stands for the sine of the opposite hypotenuse, the cosine of the adjacent hypotenuse, or the tangent of the opposite adjacent. If you see here, we know the opposite and adjacent, so we are going to want to use the tangent function to solve this problem. Eventually, you're going to want to be able to use tangent math on your own, solve for your own equations. For now, it's okay if you guys just use this equation here. The tangent of the angle times the adjacent side, in this case 16.6 meters, is equal to the length of the opposite side, which is what we're looking for. A little bit of quick math, a little bit of algebra thrown in here, a small calculation, and we can calculate the length of that opposite side.
The most common mistake people make with this is to take this calculation you just made as the actual height of the object. What we've forgotten about is that the measurement we've made calculates the height above the sextant, usually above eye level. The part you always have to consider is the height you're holding that sextant above the ground. If you're sitting it on the ground making the measurement, that's all fine. It's kind of difficult to do though. What you always have to calculate in, add in, is the height from the sextant above the ground.